Welcome to another cloud test tip video. In today's video, even though I'll focus on cloud, I will specifically speak a little bit about private cloud. Customers are investing both on public infrastructure, public cloud infrastructure, and private cloud. And they have this need to choose the right compute, right network, right infrastructure so that they can get the best bang for their buck and also ensure all the applications that they will be running or the users that they will be onboarding are able to function seamlessly as they decide on their public private cloud strategy. So, what I have done here is I've taken an ESX hardware and deployed a bunch of virtual machines and allocated 32 cores on one side to be the client, another 32 core on the other side to be the server VMs. And I have added some RAM, 240 gigs of RAMs to see some concurrency tests, and also two NICs which are able to do 200 gigs of throughput between them. Let's get to the test now. Just like any other test, I start with browse configs. I move to my performance configs and would select one of those defaults. I have selected in this case a connections per second test, but I have also changed this a little bit where I have added these virtual machines in the left hand side and the right hand side, each of them allocated with 60 gigs of RAM and 8 vCPUs like you see. So in total, they make 32 virtual CPUs and 240 gigs for client and the server. The HTTP application that I'm using is small packet so that we can go for a high number of connections. I have disabled max transactions and set it to only one, so every connection will open a new transaction, which is what would help me to achieve a lot of connections per second. And what I've also done is in the objective settings, I have set the objective to be CPS of 1.2 million, which I think is a pretty high objective for a enclosed hardware kind of test, and I've set the mode to be on rate mode. Let's run this test now. I've kept the test running for a few seconds now, and I can see the goal seeking is shooting up to reach to that 1.2 million connections per second that I have set. And we should wait for some time, and we can see that that stabilization has already started to occur. So it means that we are kind of hitting the peak of these CPUs that we can achieve. It's almost 1.1 million connections that we are doing now with these 32 cores of client, which is really pretty high, without using any specific custom-based hardware, just plain old, NICs that we can buy off the shelf. And we can also see we are even at a small packets, we are running at 4.5 gigs almost of throughput, application throughput that is with this setup. So that's kind of my initial reading of CPS. And let's stop this test and go for some other tests now. The CPS test is now stopped. So let's edit and go directly and leverage this same config to do a concurrency test. So let's go to our settings. And now what I will do is I will set the persistence to enabled. I will set a higher action timeout, and I will also increase the max transaction. So we are not trying to close the TCP connection here, but trying to extend it as much as possible. Very important is also to change the objective, because now my objective is to hit the memory limits of these virtual machines. So my objective changes to simulated user, and I will go for whatever high I can get. So I'll put a value like 60 million simulated users. And I will also change from rate mode to balanced mode. This is where we'll really try to max out the concurrency of each of these systems. Everything else is literally unchanged. And I can only one more point to make here is that you might want to crank up the number of simulated IP addresses, because if you're hitting that kind of concurrency, you might run out of available ports and IP combinations. So IP addresses are cranked up to 3000 for client and 300 for servers for each of those segments. So let's see how it goes. Just like the CPS test, I also had this CC test running for some time. I can see every tick adds another 10 million of objectives. So you can see it's right now 45 million going to that 60 million that I have set. I know some of these objectives because I've run this test before, and goal seeking already told me the upper limits of this system. So for this video, I'm setting the objective near about it. And you can see that we have achieved around 58.3 million, and my connection per second would now slow down, and my throughput is getting cranked up to around 6 gigs, 7 gigs. We can definitely go much higher with better page sizes, but this was a concurrent connection test, and I wanted to baseline the concurrent connection. For any of these tests, you can also go to agent metrics. I didn't do for the CPS, but you can go to them And you can literally see each of these instances or virtual machines. You can see them per core, you can see the available memory, and would be seeing that we are actually able to extract every ounce of juice, either it's CPU or memory, from the systems. So let's stop this test and go for our next test. Our next test would be the third of the big three, which is the throughput. And obviously, in this case, I would need as much help from the throughput as we can. So I am adding a post for cranking up the RX traffic. And for the get and post, I'm just increasing the page size that I was downloading. It's still the basic skeleton is the same test that I did for the CC and CPS. So you can see how easy it is to modify one test to achieve a completely different objective for a second test. So that's what I did. 1 meg get, 1 meg post. I go to my properties and I have set the max transactions to 10 for concurrent connection. I set it to 0, which means we'll continuously do this get and post over the TCP connections and would not increase or generate a lot of connections. In objective, obviously, we'll change it to throughput because that's available, and we'll change it to some very high value like 300 Gbps. Change the rate mode to rate mode because throughput is a rate based objective, so it will help me. I'm also going to change some of these buffers to help me with the throughput. So I'm going to go for full packets initially, and obviously Cypher would adjust its window sizes and scale to much higher window sizes. That's it. Same setup. Let's start this test and see what the results are. Just like the other test, it's running for some time, and you can see it's almost reached to the limits. It could not get to 300 gigs with the present set of hardware and network infrastructure I have, but we get to around 271, 272 gigs of good put. The layer 2 throughput will be much higher. And again, I can review some of my interfaces and CPU and see something very interesting here. We are not reaching the limits in terms of all the CPUs. So this also tells me that there is something more we can do in network infrastructure, some more enhancements like adding smart NICs, some offload capabilities, and other features that are available to get to the max limit of throughput. So we have room to grow provided we increase the network infrastructure. So now let's get back to the performance review. So I thought, since I have this setup, why don't I run a lot of other tests? You already know some of these numbers from the HTTP test, but I also ran HTTPS test where I could get 115 gigs of encrypted throughput. I also ran some application mixes with some small packet transactions like Jira, Skype, Office 365, SMTP, and you can see there is a big degradation of throughput there. This kind of gives you an overview of what's your benchmark, optimal performance that you can get when you're choosing a certain type of hardware, either for your public cloud or private cloud, but also shows you the realistic picture where if there is a lot of transactions and complex applications, how much best case scenario throughput or worst case scenario throughput you can get. I hope this has been helpful for you. Thanks a lot for listening.